Number 1, we know that the equilibrium constant for the reaction is 1.5 for reaction 1. And we want to know the equilibrium constant for this one. So we know that if we reverse it, it's the reciprocal, but let's just derive it. So K1 is going to equal concentration of D squared, concentration of E, over concentration of A cubed, concentration of B squared. So that's for that one. Now let's look at this one. K2 is equal to concentration of A cubed, concentration of B squared, over concentration of D squared, concentration of E. If you look at these two, K2 is just the reciprocal of K1. So 1 over 1.5, and that's going to be 0.67. So the answer would have been A. Number 2, what is the expression for Kp for the reaction below? Remember, solids do not count. So Kp is equal to the pressure of H2O over the pressure of H2. So that would have been E. Number 3, consider the following reaction. At equilibrium, the concentrations of H2, I2, and HI were 3, 4, and 3 respectively. So if we were to consider an ice table, these are the equilibrium amounts. So at equilibrium, we have 3 molar of H2, 4 molar of I2, and 3 molar of HI. What is K? Well, K is going to equal the concentration of HI squared over the concentration of H2 times the concentration of I2, and that would equal 3 squared over 3 times 4. And without a calculator, I can just 0.75. Okay, number 4. At 723, the equilibrium constant for the reaction has a value of 50.3. That's big. Which of the following is true? So the rate of the forward reaction is equal to, so it says which of the following is true of the reaction at equilibrium. Okay, and we have 5 choices. The rate of the forward reaction is equal to the rate of the reverse reaction. That is always true at equilibrium. The rate of the forward reaction is greater than the reverse reaction. The rate of the forward reaction is less than the rate of the reverse reaction. Not at equilibrium. A decrease in volume will cause an increase in K. Well, we know the only thing that changes K is temperature. Only temp will change K. Okay, so I think that this was the key thing. If you're at equilibrium, which of the following is true of the reaction at equilibrium? At equilibrium, it means that the forward rate and the reverse rate are the same. So the answer to this was A. Number 5. Which changes will increase the quantity of iron for the reaction below? So this is delta H is positive, so the delta H would go over here. It's an endothermic reaction. If we increase the temperature, that means we would increase this. The reaction would want to decrease it, so it would shift to the right. If it shifts to the right, it is going to increase the iron. So number 1 is true. If we decrease the temperature, that means that we would want to increase it. We would shift to the left. That means we would reduce some, so that's not true. Adding Fe3O solid. Now let's take a look at that. K equilibrium is equal to H2O to the 4th over H2 to the 4th. The equilibrium position is only affected by the gases or the aqueous. Remember, these were solids, so that's not going to matter. So the answer to this one should have been 1 only. Number 6. For which of the following reactions does Kc equal Kp? Well, we know that Kc equals Kp times RT to the delta N. So we need to find a reaction that has a delta N has to be 0. Because when delta N is 0, this whole thing is 1 if delta N is 0. So Kc would equal Kp. Oops, I'm off, sorry. So we know Kc is equal to Kp times RT to the delta N. So if delta N is 0, that becomes 1, and Kc would equal Kp. So we're going to look at these reactions. 3 moles on this side, 2 moles on that side, it's not that one. Solid doesn't matter, solid doesn't matter, gas, not that one. Solid doesn't matter, 6 moles of gas, 3 moles of gas, no. 2 moles of gas, 2 moles of gas, 2 moles of gas, 3 moles of gas. So this one has to be D. For D, the change in the number of moles of gas is 0. Okay, number 7. A sealed isothermal container contains 4 moles of methanol gas. The reversible reaction is given. At equilibrium, there were 3 moles of CH3OH in the container. What are the total number of moles of gas present in the container? Okay, so we have CH3OH is in equilibrium with 2H2 plus CO. We have 4 moles initially. At equilibrium, there were 3 moles. That means that we lost 1. It's a 2-to-1 ratio, so we gained 2 and we gained 1. There were none in there to start, so we have 2 and 1. 3 plus 2 plus 1 is 6 moles total, and so the answer for this one was C.